Let's now consider review problem 2.5. A bank deems its credit rating system to be satisfactory if it correctly assesses the worthiness of at least 80% of the bank's customers. In a simple random sample of 20 clients, only 13 were correctly assessed. Is this enough evidence to think that the credit rating system is satisfactory? So in this case, the null lets pi be the probability of a correct assessment, whether the person is worthy of a loan or not worthy of a loan. The null hypothesis in this case would be that pi is equal to 0.8, that the system works. The alternate hypothesis would be that the system does not work. Okay, now let's assume the null hypothesis and work through the logical ramifications of making that assumption. As usual, we take alpha to be 0.05 unless the problem states otherwise. In this case, I have 20 trials, and I have a test statistic of 13. So my p-value will be the probability that I have seeing something this extreme or more extreme. In this case, extreme means 13 or less. I would have expected 16 people under the null hypothesis to have been correctly assessed. I only got 13, so what's the chance of seeing something like this or something even more extreme? So the p-value is equal to the probability of 13 or fewer successes. In Microsoft Excel, the command goes pinom.dist of 1320.8 true. There is a similar command for a TI-83 calculator, and for that command I'll refer you to the other videos where the binomial distribution was applied. But using Excel, we need to find the chance of 13 successes or less, and we get an answer of 0.087 basically. So this number is bigger than alpha, and so to save myself the trouble of trying to write this, I'll type it out. We retain or fail to reject the null hypothesis. We do not have enough information to reject the null hypothesis because the p-value is bigger than alpha. So it appears that the credit rating system is working satisfactorily. Okay, so that is the procedure for doing this problem. We define the value of pi. The null hypothesis is that pi is equal to 0.8 in this problem. The bad thing to happen would be that pi is less than 0.8, so we call that the alternative. And then we assume the null hypothesis and kind of see what happens.